So I think we're ready to start. Good morning, everyone, and welcome to July's ALASCA Tech-Talk. Today we have Tech-Talk number 38, and I will be walking us through today's session. We have a short agenda as usual. We will start with today's Tech-Talk, followed by a short discussion, and then we also have a slot for news and events. Where we will present some of the activities that ALASCA has been conducting in the past month. And then we will close off with an announcement of next Tech Talk in August. So today we have a talk that's going to be presented by Friedrich Zahn from ALASCA FOCIS and Daniel Gerber, also from ALASCA FOCIS. So they will talk today about going full Arctic Circle, running ALASCA on open cloud infrastructure and standards. This is a very refreshing title, especially considering the temperatures at the end of July. So without further delay, I will hand it over to you, Friedrich, Daniel, and yeah, we're looking forward to your talk. Thanks.
Yes, that is what we are. That is what we want to talk with you about. We want to go the full circle, and we want to tell you a little bit how we run ALASCA on open cloud infrastructure and on open standards. And this is the first for us here with two people in front of one camera, so please be aware of that. I think I just get into the presentation, and first of all, we wanted to start with we want to have a cheer out to the sysadmins, which today is the World Sysadmin Day. So if you are one, congratulations. If you know someone, then go tell them they do great work. You might have heard this already. We are part of ALASCA. We work in the FOCIS project, which is an acronym for Free and Open Cloud Infrastructure. Cloud Initiative Saxony, and we are funded by the Free State of Saxony, and we are very grateful for this, and all the work I and Friedrich will present to you are co-financed by the Free State. So what do we want to show you today? First of all, we want to give you like a brief or a top-level overview of all the stuff we are doing here in ALASCA in the FOCIS project, or at least most of it. Then we want to dive into 4 different topics where we run different services on open standards and tell you what worked for us and what did not. And last but not least, we want to give you an overview on how we want to tackle open built infrastructure for ALASCA in the future. One request we got from some people was that we should include an ALASCA WIML build in this presentation. I only managed to insert one WIML build. To insert one from ALASCA was a little bit too difficult, but maybe there's some great artists in the future which could generate one maybe from the ALASCA Summit. But we settled now on a different metaphor, which you might know better in the context of ALASCA, and this is an iceberg, and you typically see only our 7 projects. We do have 7 projects in ALASCA which focus on open cloud infrastructure, and obviously there's a lot more underneath the surface. If you have been to the talk earlier today, you know that Cloud and Heat sponsored us SCS compatible IaaS environment, which we internally call DD8A. We are very appreciative of this. Thank you very much. And within FOCIS, we created a terms of use to get access to the resources. And if you are in need of those resources, you can apply for that via the email shown here. We use these resources to help friends in our ecosystem, and we manage these friends and accounts and so on in an identity management system, which Friedrich is going to present in a bit. But I just want to give you like an overview what we are using this for. We're using this internally for our focus team for Taruk and Yauk installation, which we use in the SCS context. We use this for the Turing FAO, which does some experiments with OpenDesk. We are using this for Fediway, which try to improve search within the Mastodon Fediverse. We work together with FOCIS. They're doing geospatial information systems. And there's this project called ElbForge, which is a code management system you might have known, or you might know Codeberg. And this is similar since all of the systems use ForGeo as a backend system. There's the Sonic community build, which is something we recently came up with in Alaska. It's it's not a real project, but it's becoming one, I guess, in the future. And there's Yake, and last but not least, Pacifico, who got resources to experiment there. If you go even further down, then I have this quote for you, what was given by some time ago in an internal meeting, and someone asked the question, do you want to have hedgedogs? So this collaborative work on nodes. And someone says, sure. Okay, then the journey of us started, and we needed to ask ourselves, is hedgedog up? So we need a status monitor, we installed uptime. Is the hedger? Then we needed to install traffic and let's encrypt certificates. We came across the issue on how do we share the admin password or other passwords in that matter within our team, and we needed to install a password manager. You obviously need to log into the password manager, so we installed an identity provider, in that case Keycloak. And of course, we always want to have services up to date, and we install Renovate. Then if systems break, it's better to have backup and restore ready. And of course, you have to document everything. So you need to configure like a wiki, which you can reach at docs.alaska.cloud. And obviously, you need everything code repo. Yes. So, but you can go even further. We now provide a handshard repository for the Thanos handshard, which was done in co-work operations by the Taruk and Arco team. We run GitLab Runner Manager in an active setup, which we talk about later in more detail. We have a work in progress for Woodpecker CI, which is connected to multiple forges. We have Grafana and Prometheus that we need to have in order to monitor the GitLab runners. We have an OpenStack billing dashboard to measure what our friends are actually using. We have the SIG standardization and certification that Matthias takes care of. We have a public issue board. We have an SCS compliance monitor setup, and we have the Alaska WordPress backup, WordPress website. We have 19 mailing lists. We have DNS entries, and if you ever had to set a PTR record for an IPv6 address, you know that is also some work. We have the Alaska Summit, the Tech Talks, podcasts, Mastodon, LinkedIn, YouTube marketing, and so on and so forth. So we only can show you a little bit of that. So with that, with all that said, I will give over to Friedrich, and he's going to talk to you about our managements of friends. Friedrich?
Yeah. All right. Thank you very much for this overview. So let's zoom into 4 very specific use cases from that long list Daniel just presented. And these were all basically selected based on our desire to really look into the open standards we work together on with the SCS community, and that we are tasked to promote and further improve, and really to see we as a cloud customer that we are basically at ALASCA, how do we can actually make the most of it, and maybe also to see what breaks when you try to use them. So that's kind of the idea here, to really show this. And so we started off, first things first, once we got this SCS compatible cloud environment sponsored by Cloud and Heat available to us. We got the first requests. We needed to onboard more people, more projects. So the very first thing we needed was some kind of identity management, and we really wanted to align with ALASCA's general values in an auditable manner, a solution to manage all these identities and the resource allocations on that sponsored cloud. And Daniel already showed how many entities and stakeholders there are to manage. Some stuff is shifts. For example, we at Focus do workshops sometimes where we need to give people, third parties, access in a secure manner to these cloud resources for a few hours. On the other hand, there's really production grade running there, such as AlphaForge, where people want to build something long-lasting, and we have to bring this all together in a technical solution. And so we had a look, what does SCS and the open standards we work on offer there. It's pretty straightforward in this case. The domain manager role for OpenStack is a mandatory part of SCS compatible IaaS. It's written in SCS 0302. The domain manager role itself is actually by now an upstream part of OpenStack, so nothing too special, but still SCS mandates that it's available to customers. So yeah, we made use of that. We requested our own domain and domain manager access to that. And for the technical solution, we went with an open source infrastructure as code approach. So it's basically just one long OpenTofu, formerly known as Terraform, file that uses the OpenStack provider as it is, just to keep track of all these things. And for the basics, this worked really well. We've been now using this for quite some time, and it's quite pleasant to work with usually. So as you can see here, it's also not super complicated. Just a few lines to create a new project, to create a new group, and just the same to create new users and then assign them to groups. And again, these groups then get role assignments to control their permissions. What are they allowed to do in which project and so on. So that's working quite nicely. You can find it on our GitLab actually, if you're interested in that. What didn't work? So we were hoping maybe a bit naively, but of course customers never actually read all the documentation, so we did neither, that the domain manager would also maybe be able to actually manage the quota allocations across all these projects. But that's not the case. It's simply not within the OpenStack policies for that role. And generally, we found it a bit lacking in regards that OpenStack makes it quite hard to have like hierarchical abstractions of quotas and aggregate them or anything. That's at least not something that comes out of the box. And we couldn't really find a good way around that with a like manageable effort. So we fell back to a quite basic approach where we just request quotas for each project via mail to our CSP. And then to aggregate them, we have to track them in a spreadsheet. So that's for sure room for improvement. But it is what we could do with the stuff given to us, basically. And something else that builds on that, of course, when you assign quota to projects, it's also kind of nice to have an idea whether people are then actually using that quota, or maybe you could ask them to give something back and so on. And also, as we will soon talk about, we have some more sophisticated cloud applications where stuff is auto-scaling and so on. So you also want to monitor the actual usage in your cloud environment. And of course, we are happy and lucky that we get a sponsored cloud. But as a normal customer, of course, you're also very interested in the billing aspect of your cloud resources. Cost control is a big topic among cloud customers that we talk to. Yeah, but that also was something we found that couldn't be really realized with the onboard tooling and what SCS has available. There's simply no requirements towards pricing or billing in any way, neither an API nor UI or anything. So we were very happy to see that in the ALASCA ecosystem, there was a project which was very new at that time, but we were happy to try it. Back then it was called Raclette Billing Dashboard. Now it's known as RacStack. And so we are using that. Daniel will tell you much more about it later on. And to work around the authentication limitations the domain manager has, we just use a dedicated user in projects that opt in to being monitored. And before we show you RacStack now, we of course need more stuff to actually show off in the RacStack visualizations. So first, Daniel will show you now some of the auto-scaling use cases we have.
Yeah, I will. Basically, something every project within ALASCA needs is continuous integration and continuous delivery infrastructure. And within ALASCA, I already said we have 7 projects, and there are scattered around different folders. We have 2 projects now in GitLab, one of which I think tries to move to GitLab, 4 are in GitLab, and one is even in Codeberg. And I told you that we will have our own forge on our own infrastructure. You're probably all you can all join that in the future if you want. So we thought that we start off to make the life of the project in GitLab easier, and we want to use our system that we have available. So we have an IaaS cloud. And yeah, if you don't know GitLab Runner Manager, it's basically, or GitLab runners are similar to GitLab Actions in GitLab. And why do we want to use them? We want to have isolated throwaway VMs, which don't share any state with other projects, which you can throw away after they done the one thing they were meant to do. And with that, you obviously get more security. It builds on the GitLab Runner instance group autoscaler, which provides different plugins, one of which is the fleeting framework. And this is a library that you use to provide plugin-based abstraction for different clouds. And I want to ask you a little bit of a sarcastic question. Which cloud providers do you think are officially supported? And yes, the question is the typical 3. And if you go a little bit further about what community projects are documented officially, then of course the answer is VMware. So no help for us there, and we had to dig a little bit deeper. And fortunately, Friedrich found this project by Sardina Systems, which is called Fleeting Plugin OpenStack. It's on GitHub, and it basically works like this. You have a GitLab instance. In our case, it's gitlab.com, and the GitLab Runner Manager, and it pulls for pending jobs. If it finds one, then it creates a VM within our SCS OpenStack engine, and then it creates a new fresh VM with a volume and runs the job, and afterwards it destroys that resources. Why did we do that, and what did SCS offer here that we can leverage? We know that image upload must be available. We know that we have mandatory flavors which we can use, and there was also a little bit of a problem where we try to use a special CI build image, in our case Flatcar, but this is not part of the SCS standards at the moment. Okay, so in our work with the system, we had some issues. The project is basically configured with an ini file, which makes it very hard for us to configure it dynamically, especially for the UU IDs, which change maybe after you upload a new build image. And you also manually need to provide and maintain the build image, which we automated. Also, the project configuration is now done with Jinja templates and some small helper scripts. And the probably biggest problem is that it's poorly maintained. And we are in discussions with some people from Helmholtz and Sys11, and we are going and try to move this within to ALASCA. And now to the fun part, I want to tell you how to deny the service your own cloud. All you need to do is you need to configure your runners with ephemeral storage, and then start a bunch of servers or a bunch of runners go and once you come back, you see that there is no valid host found anymore, and you don't know why this happened. OpenStack does not give you any helpful messages, so you have to go to your CSP, ask them. They can find out what's wrong, and then you change your system to use volumes, and everything is fine again. You can find the source code for the setup at our configuration repo in the ALASCA group. And all you need to run this is a GitLab runner token, OpenStack project with an application credential and a host, which could be your laptop, and run Docker Compose app. If you want to have your own runner, please contact us. And yeah, that's basically all you need to do. So now I would give over to Friedrich, and he is going to tell you something about Woodpecker autoscaling, which we need in terms of, so if we want to move from closed source Forge like GitHub to open core Forge from GitLab, and then we have the real open source Forge for Geo, which needs its own runners, and those are Woodpecker CI runners. And please continue.
Yeah, as Daniel already said, so and there was also this nice table just before. Our projects at ALASCA are now spread across at least 3 different Forge platforms, and we expect that number to only grow. So we were looking for more options, and maybe also for possibility to decouple basically where the code lives. So the Forge and the CI implementation, typically these are very closely connected. So you have GitHub Actions on GitHub and GitLab CI on GitLab, and Forgeo Actions at Forgeo, which makes moving, of course, then much harder. And the nice thing about Woodpecker CI is that it's basically independent of the specific Forge. They're using OAuth to allow you to access different forges, even from the same instance of Woodpecker. So yeah, we just wanted to open up more options to the projects, to maybe move beyond their current Forge platforms. And of course, we are again looking, okay, what can we learn about open standards here? How can we make the most out of our open cloud platforms? And of course, also, yeah, moving the CI implementation shouldn't be like have drawbacks. So we wanted to get have feature parity somewhat there. And we quickly realized that the Woodpecker CI autoscaler does not yet support OpenStack in the way as you've just seen for GitLab CI. But luckily, the solution to that problem was not hard to come by. And during the ALASCA hackathon just a few weeks ago in Stuttgart, we managed to polish up an existing pull request in under 48 hours to the point that there's now, it's already merged. There's now an experimental OpenStack provider for Woodpecker autoscaler. Everyone can use, of course, also way beyond the ALASCA and SCS sphere. So we are very happy with that. And yeah, the implementation is a lot similar to how also the GitLab CI autoscaling works. So I'm not gonna talk too much about that. Just to give you again an idea, it's very similar. On demand or as configured, the autoscaler spins up instances as needed. And then, of course, also takes care of registering them on the Woodpecker platform itself. They call it agents. GitLab calls it runners. But it's yeah, very similar in the end. And we are happy with that. It's already working for us quite well. And we are looking to get this into production for the ALASCA projects. And yeah, to talk a little more again about the open standards. This was because we were yeah, quite quickly done with the OpenStack provider itself. We also wanted to look at the hackathon whether we could manage to like get this even more streamlined using everything SCS has to offer. And so we try to implement basically an SCS provider, which is even more specialized. And some stuff was very easy, as Daniel already said. There are the standard flavors, for example, so you can just hard code basically the string, and user doesn't have to worry about it. Very basic. But we also tried to use the one SCS mandatory image, which has to be available on every SCS certified cloud environment, which is basically just the latest Ubuntu LTS image. And some time ago, someone from the SCS community even published documentation on that, on a heuristic to determine, to find this image based on the metadata SCS mandates to be present. So we just tried implementing that in Golang, which was not one of the example languages. So we had to come up with some logic ourselves. But we quickly realized that this filter logic supplied by SCS actually selected a more or less random snapshot I created earlier instead of the image we desired. Because as we realized, snapshots in OpenStack are quite hard to distinguish from like actual images. They inherit all metadata, and the glance API is a bit special. So this was not like foreseen by the SCS community. We added some code to basically quick fix this, filter out all snapshots. Not impossible, but we had to do it. And so now we are again trying to give back, of course, and we already opened a bug report and are now in the process with the SCS community to further refine both the documentation on this image lookup logic and also the standards to just make this more seamless for the users. Yeah, so now we have two autoscaling applications on our cloud environment. Some of this autoscaling is even triggered by forces that are hidden to us. So it's of course then nice to see how it's actually used. And that's the point where we come back to RacStack, and that's Daniel's topic.
Yes, RacStack. We need to measure what we use, what our ALASCA friends in the ecosystem use, and yes, I already said that. Another reason why we use it is that within Focus we are looking for commercial use cases especially within Saxony, and we are trying to equipping with vision monitoring. And so this project is, I think, a perfect fit here. It is developed on top of the Raclette.js framework by Pacifico, which is also an ALASCA member. You can find the source code, which is under MIT license on GitLab. The same with the issues and the documentation. You can join their matrix room. They're very chatty. They're very responsive. Big shout out here. And the tool currently needs the Keystone, Nova, Gnocchi, Cinder, and Neutron APIs from OpenStack. Yeah, there's some talk later where I tell you a bit about how that should fit in the future into the SCS standard. But in general, what I think it is ideal to measure our Woodpecker and GitLab CI runners and the volumes and the folding APs and all the stuff which belongs here with that tool. So the features, it basically has currently, it measures instances, folding IPs, and volumes. You can easily install this with a simple Docker compose command. You can configure a dashboard to only see the parts which you want to use, or be it charts or be it tables. I will give you some screenshots later. You can import your users' data as X-Berechnung and Zugpferd, which is also part of the so-called Deutschland stack. And you can adjust the billing and pricing very freely. You can have like system-wide defaults, which get overwritten by customer defaults and which get overwritten by project defaults. So you're very free to let every customer pay what you think they should. How does it look like? This is the dashboard here where you configure what you want to see. It's all drag and drop, so very easy, even for me. You can define all the flavors and the pricing for that. You can also add all missing flavors, which was very easy to get them all in a table. And then once you've done that, you will see those breakdown charts where you see exactly how you spend your money, or what each individual VM costs. You can also see this in a table format. You can see when it was created, which flavor was used, how long it was used, is it still active. You can filter this on any given property. As I said, you can export this in different formats. So this is a very useful tool for us to get an overview of what you're actually running. So the issues we came up with, Friedrich said that already at the beginning. Since we don't have admin credentials, admin privileges in our cloud, we are currently limited to a single project view for a single RacStack instances, since the application credentials are always project scoped. And I also said this already, the metering is currently only in draft status within SCS. You can see the SCS 04XX standards here. And this means that it's also difficult for app providers like Pacifico to build one system which works on all clouds. So I think it might make sense to look into standardizing the metering stuff there. And there is one contribution to the debate which I published yesterday within the GitHub discussion site of SCS. Yes, but I don't want to go into detail. We want to use the remaining time to do or to tell you more about what we think this means actually for our operations within ALASCA. So, Friedrich.
Yes. Thanks. So yeah, at this point, you've seen these 4 very specific use cases. I would like to circle back to that picture from the beginning now of this iceberg metaphor. So on the top, you have all these projects that people are happy to use. And Daniel showed you a lot what lies beyond the surface on the ALASCA side, what we have now been working and building on. But there's also a second dimension actually to that. Because I think for historical reasons, but also because just the ALASCA projects are always very free to do what they want, to do what they need. Many operate basically on a bring your own infrastructure approach. So like beyond the pure use of these projects, there's a lot of infrastructure going on there as well. So there are image registries, some of which see a lot of traffic volume to the degree that they were actually kindly asked to leave GitLab.com infrastructure with that. There are chart registries for the different forges we showed you. There are CI infrastructure, CI capacities. The GitLab CI runners we now run for the Yaook security project is just one tiny piece of that. And yeah, and then beyond that, again, some of these CI jobs that are used to test and build the various projects, they again have requirements, dependencies on other infrastructure. For example, Tarook has a lot of OpenStack integrations, so naturally they require an OpenStack instance to test their software against. Yaook is running on Kubernetes, so of course they need a way to spawn Kubernetes clusters in different versions to make sure that Yaook is working on different Kubernetes versions. So that's like another dimension that's currently kind of the service, and that kind of leads to the question, since ALASCA is the Alliance for Open Operational Cloud Infrastructure, that's obviously the goal that we want to facilitate. But yeah, if you're kind of nitpicky, operational in this context, of course, means that you should be able to use these software solutions in ways that you see fit. Maybe you want to build a product on top of them. You want to be able to modify and distribute the projects as you need. And I think this parallels a lot of the general discussion of free software versus open source, but I don't want to get too deep into that now. But if you basically in the year 2026, if you have such a complex cloud level solutions, if you can't test and actually build all the artifacts that are needed to run them, then yeah, you're very limited in what you can actually do with them. And there was also now this Sonic community build Daniel already mentioned, which really exemplifies that. It's a network device operating system, which is open source. You can find it on GitHub. But in practice, a colleague at Cloud and Heat has now been working, I think, nearly half a year on actually bringing a community build to life. The build process is very complicated, takes a long time, is prone to failure, and has dependencies such as a lot of the images used are hosted at Azure. And apparently Azure is happy to rate limit you once you try the third build of the day. And this is, of course, not something we want to replicate. So for the reminder of the focus project time, this is something we want to address to improve the transparency and reproducibility within our projects. And as a first step there, we have just set out to document the status quo. We already did some work on that behind the scenes, but now we would really like to do a kind of test run to bring more of this whole build process and infrastructure to the surface and have it transparently documented, which I think is also a big factor in terms of trust. That, of course, helps to see what's going on. And then we just hope to distill and refine guidelines based on that, to be able to also give some recommendations to the other projects, how this is actually doable. And there's also an idea in the long term to have this then formalized as part of the TSC project guidelines to make sure that the projects make sure that this is documented. So there's also a call to action here, of course, if you have experience with that and would like to give us some advice, or also if you're working on one of the projects and would be interested to collaborate, feel free to get in touch. And that's also where we are coming to a close. Here you find all the various ways that you can get in touch with ALASCA and us. I would like to thank you for your attention, and I think we are open to questions now.
Perfect timing. We're also running out of air in our room here.
Thank you very much for the presentation. And yeah, the room is open for questions or for comments or any discussion. There was a comment in the chat. I don't know if you've seen it from Christian Berendt with some reference to other possibilities that you can use.
Yeah, I saw that. Unified limits in terms of managing quotas in OpenStack is something we came across. But we were really approaching the whole problem from this customer perspective. So enabling or changing OpenStack features on that level is not something that you're able as a customer, but of course there are there's work on the way in the OpenStack community to address this, and of course going forward I think we would be happy to maybe together with the RacStack team have a look how this can be improved and maybe incorporated in the SCS standards so that we can rely on these functionalities.
Okay. Any other questions or comments or ideas?
Who wants a runner?
Any candidates here?
We give them. No, but seriously, if you are interested in any of the projects, please feel free to contact us.
I see someone is typing. If you have any questions or you want to add anything, you can just unmute yourself or type it in the chat. Okay, some positive feedback. No question in the chat so far. Okay, last chance. 3, 2, 1. Okay, so you know how to contact the Focus team if you have any questions or you want to try something out. Thank you very much for the presentation. And now we have a few minutes. I would like to use them to share some news of Alaska. So it's loading. Hopefully it comes on soon. Do you see my screen already? Yep. Okay, great. Thanks. Okay, so some news or some information on what's been happening in the last month in Alaska. First, at the beginning of July, there was a hackathon in Stuttgart. I wasn't there myself, but I see that many of those of you who are here today were also there. I've heard that it was a very successful event, including also an invitation to Hurutech's summer party. So from what I've heard, it was a good opportunity to dedicate some time to some of the ideas that the Alaska community has. And overall, a very successful event. You can also find a summary or more information on the Alaska website if you have some interest in looking at what happened there. Then there was also Alaska's yearly General Assembly a couple of weeks ago. So as usual, all the Alaska's members came together to discuss the activities of the last year, to take a look at what the association has been doing so far, and also to figure out how the association should be developed further in the next year. And there are some interesting news. First, the board of directors of Alaska was expanded. So in the past, there were three members of the board, and from now on, there will be 7 board members. So first, congratulations to the 3 members who have been re-elected. That's Cloud and Heat, represented by Marius Feldman as a chairman, Josefina Seifert, and Stackit, represented by Stefan Paus as treasurer. And then we have, the General Assembly elected 4 new members, which you can see here. So it's Vera Böhner, Daniel Gerber, Christian Berendt representing 23 Technologies, and Matthias Hack representing Hurutech. So also congratulations to the new members, and it's great to see that Alaska is growing in so many aspects. Also, a code of conduct has been passed in the General Assembly, which is now accessible online and which regulates how the community works with one another and talks to each other, and the kind of environment that's expected from the Alaska community. So you can also take a look at that if you're interested. And Before we finish today, I would also like to mention the ALASCA Summit, which is mentioned in every Tech Talk, but today is a very special date because today is the deadline for submissions. So if you have any ideas to contribute to the ALASCA Summit and you haven't submitted them yet, then please do so in the next few hours. So you can submit short talks, you can submit longer presentations, you can also submit workshops. And yeah, so every contribution is welcome, and yeah, bear in mind that the official deadline ends today. You can also register for the event if you haven't registered yet. The link is here, the link is also on the website, so that's also something that you can do, but mustn't be done today, but you can also do it today if you want to. And also in relation to the ALASCA Summit, there's quite a few rooms that have been reserved at the Mighty Twice Hotel. That's also the place where the conference will be taking place. So you can also book your rooms. Yeah, you can see here the instructions. They are also available online. Just write an email to the hotel and or call them and let them know that you are booking for the ALASCA Summit with the keyword Alaska, and those rooms will be reserved for you. So it's a really cool location. The hotel is also very nice, and it's very practical, of course, to stay at the same hotel where the conference will take place. And with this, I think we are finished for today. As always, stay tuned. Take a look at our communication channels of the ALASCA Association. And if you have anything that you want to share, just write to hello@alaska.cloud. The next Tech Talk will be at the end of August, last Friday of the month, as usual. And we already have a speaker for that. It's Simon Maya from Excellent Technologies, and he will be talking about CRO from Helm charts to Kubernetes APIs, rethinking meta control plane deployment. So that's the next opportunity to listen to a Tech Talk. I hope that you will be there. And otherwise, thanks again to Friedrich and Daniel for the presentation. And thank you all for attending. Have a nice end of the summer. Hope it's not too hot. I'm sure it will be, but yeah, enjoy the next few weeks and see you next month at the next Tech Talk.
Bye.
Bye-bye.
Bye.
Thank you. Bye.